All right, hi everyone. Welcome back. This is going to be the third and final video for our landscapes and groundwater little mini thing. So we're still in this packet that you guys should have all received, and we're going to be on page 11 starting off. Looks like this. All right, so let's jump right in. Take notes like you normally would. Remember, I'm going to be collecting this when we get back from break. Okay, so landscape regions. So when we talk about landscape regions, this is really broken down into three topics, but let's really just define what we mean by landscape as we go. So a landscape is a region on Earth's surface in which landforms have a common origin. Okay, what does that all mean? These different structures that we see across the surface of Earth oftentimes come from the same things. All right, so make sure you write that down: landscape, region on Earth's surface in which landforms have a common origin. And of course, you know, if this is going to go too fast, just pause the video. You can rewind, all that fun stuff. Okay, let's move on. So we also have these two definitions here: topography, okay, and relief. Topography shows the shape of the land. It highlights various landscape regions. We talked about this in detail earlier in the year when we looked at topo maps, right? We were talking about latitude and longitude way back in like September, October, and we see our changes in elevation. That's what topography shows. Relief is that change in elevation, okay, and that can be shown in the map on the right here. Everything in red is going to be a higher elevation, and everything in the other colors, blue, is going to be the lowest elevation. Okay, so that's topography, and that is relief. So when we look at landscape regions, there are three major types that we talk about. And the important thing to understand here is that we classify them based on what they're made of, based on the bedrock, and based on their elevation. So those are the two main things. Write that in the middle of the page. There are three major landscape regions classified: bedrock and elevation. Okay, make sure you have that down. So these three regions are called plains, plateaus, and mountains. So let's talk about each one of them. We're going to start with mountains. These have the greatest relief, right? So they're going to have the highest elevation. Some of the features we see are peaks and valleys. The bedrock is non-horizontal, meaning there's usually some bends and some folds in it. It's not going to be flat. It's going to have tilted in some way, usually from tectonic activity, mountain buildings. As the plates collide, the rock gets twisted and bent and broken, as well as shifted and turned upwards. So we can see that in this picture down here. If we look at the bedrock, you see it's all wavy, it's all curved, faults, right? Some earthquake faults here. So non-horizontal bedrock. It's usually metamorphic. As a product of this mountain building, there's an immense amount of pressure, and that's going to metamorphose the rock. All right, so the mountain building will make metamorphic rock. That's very common. We see in mountains. If you look at the New York State bedrock map on page 3 of your reference table, you'll see that the Adirondack Mountains here in New York, for example, are going to be made out of metamorphic rocks, and we'll get to that in a little bit. Okay, so that's mountains. Plateaus are the next one. They are medium relief. They are several stream valleys, okay, that will run through them. The bedrock structure is flat, and these are usually made of sedimentary rocks, so the layers of sediments that compact and cement over time. Okay, so we have a couple different ones that you don't need to write down in your notes, but just to compare, the Catskill Mountains that we talk about here in New York are not actually mountains. They're a dissected plateau. And even though they have a pretty high elevation, we're classifying this by the bedrock, by what it's made out of. It's made out of sedimentary rocks. Therefore, we do not consider it to be a mountain. We consider it a plateau. The Adirondacks are true mountains. They have metamorphic bedrock. So that's going to be an important distinction there. Okay, let's go on to the third one, plains. Okay, the plains have low relief, the little relief, which means low elevation, and they're going to be relatively flat. So that's pretty straightforward, and that's now going to be on page 12 of the notes packet there. Put those three things for plains there. And let's now go on to talk about how climate influences this. All right, so how does climate influence a landscape? Remember when we talked about the factors that affect climate? We have elevation as one of them, your distance from sea level, your latitude, that kind of thing. But this also is going to have an effect on the landscapes themselves. So the amount and the distribution of precipitation is going to influence the landscape. So how much rain, sleet, snow, hail, and how widespread it is going to change the landscape. And really what we're talking about here are two different things. We're talking about, is it going to be really wet or is it going to be really dry? Think of a a very wet location by the water versus a nice arid desert. Okay? So let's talk about both of these. Arid is dry. These climates generally have thin soil with little dirt on top. That's the humus there. They have sharp angles and steep slopes. Oops. Write those down for arid and dry, and you can see this in the picture here. We see sharp angles, steep slopes, right? It just drops right down the landscape, peters out over there. All right, that's our typical arid thing. Think of a desert when we're dealing with an arid landscape. If it's in a moist environment, right? So if it's something that's going to be much wetter, we're going to see a thicker, richer soil, and you're going to see more smooth and rounded features. The water helps to, with that abrasion with the soil, helps to round out the particles, so we're going to see it much more rounded. The vegetation, the life also tends to break and, erode and weather the rocks down. So this is a picture of a more humid landscape region, right? So it's going to be more moist. There's going to be a lot more water. Okay, so make sure you write both of those down for arid and moist. Okay, so a couple other notes here. Softer rock is going to erode faster than harder rock. So the composition of the rock, remember the minerals, the hardness of the minerals, a soft mineral like talc versus a hard mineral like quartz. The softer rock is going to erode and move faster than a harder, more durable rock. Okay? The more durable layers are going to form the steepest slopes of the cliff. Okay? So in this image down here, we see exactly that. This rock layer is harder, so it's more resistant to the weathering, but the water that splashes down here to this softer rock is going to break it away. And eventually this, you can see a crack starting to form here, eventually this will fall down too, and over time the land will recede as the water flows. But the harder rock is going to be more resistant to that. We see this in areas like the Niagara Falls here in New York, where you can actually trace back the history of how the rock layers and how it has receded over time. And we've used this to help to get kind of a picture on the age of things here on Earth, to date things. Okay? So the more durable the rock is, it's going to form the higher portions of the landscapes. So the plateaus, mountains, and even cliffs. Okay, so that's landscapes. Now we got to talk about drainage patterns. So how does the water flow? Right, when the water rains down on the top of a mountain, let's say, it's got to go somewhere. Gravity is going to pull it down to the lower elevations. And water follows the path of least resistance. So it's just going to flow wherever is easiest for it. And as it turns out, there are different patterns that the water tends to flow in based on the type of landscape you're dealing with. So, at the top of page 13, write this down for drainage patterns, okay? It is the way that water flows off the landscape, and it depends on the bedrock structure. So it depends on what the rock is made of. Think about pouring water over a landscape region, right? If you poured a cup of water on top of this mountain here, how would the water travel? That's what we're trying to think about here. So, drainage patterns are determined by the way that small streams or tributaries join larger streams. Okay, that's already written for you in the notes there. Okay, so let's look at the different patterns. So, first we have a radial pattern. This is very common in mountains. Water flows in all directions. So if this were the top of the mountain here, it would flow outward in all directions going downward. Okay, pretty straightforward. That's called a radial pattern. The next one is called dendritic. like a dendrite, it is a branch. So it almost looks like a tree branch flowing outward. This is very common in plains areas, very flat, so it can just flow out and just you have different branches of the stream start to meander and flow down. The water branches together, it might rejoin, it might spread out. Okay, but that's called dendritic. The third one is called trellis, also called rectangular. Okay? When we look at it from above, it kind of has this rectangular pattern, and it's actually because of the plateaus that it's in, and we see folded or faulted bedrock. So if we look at these rock layers, as the rock has been bent and eroded away, we see the ability of the water to flow along these flat lines here, making this rectangular pattern. So we call that trellis. Okay, and finally we have annular. So an annular drainage pattern is when an igneous intrusion is exposed at the surface. So if you look at this picture here, we have all these different rock layers, some sedimentary, some igneous, but then we have some magma that was pushed up, right, and eroded away at the surface, and it kind of makes this circular pattern here. So we see these dendrites coming out of it, these branches, but at the top we see this kind of circular flowing around it. So when we look at it from above, we call that annular. All right, so those are all the drainage patterns. That's everything we need for that. But we're going to skip this picture here. But what I want to do is talk to you guys about this here. So this is on page 2 of your reference table. So it's in the notes packet now on page 14, but you should also have it in your reference table. And what this page shows us, we haven't looked very much at this page, but it is the generalized landscape regions of New York State. Okay, and here's the Adirondack Mountains, so that's a landscape. The lowlands are up here, which are plains. Okay, the lowlands down here. Here's the Allegheny Plateau, the Catskill, which is, we call it the mountains, but it's really a plateau. So you can actually look at what the landscape is for the location that we are. So if you look down to Long Island, we're called the Atlantic Coast Plains. So Long Island is relatively flat and low-lying. It's a plains. Okay, so you can see that for each of the different areas of New York State. Now, if you feel so motivated, you should color this in to match the landscape region. So have a different color for mountains. Let's say you do red, yellow, blue, or red, green, blue, whatever it is, and paint or color in all the areas that match the corresponding landscape region. Okay, and if you want to do that in your notes, you can, because that way when you're not going to mess anything up in your reference table. But the point of that is to then do the same thing on page 3, which this map you guys are very familiar with at this point. We looked at this map in terms of latitude and longitude. We also looked at this map in terms of rocks and minerals. But now you can actually see the landscape regions of this, and you can compare. So if you choose to make the mountains red, well, over here we see the Adirondack Mountains. And then if you compare it to this one, oh look, the Adirondack Mountains make the same area red there. Okay, so that's from page 3. And you can also see some interesting features there, like look at the rocks. So here's the Adirondack Mountains, and then, wow, they're pretty much all made of the same rock. And what is that rock? If we look down, oh, middle Proterozoic, that's its geologic time period, which we're going to talk about soon, and it's made out of gneisses, quartzites, and marbles. Guys, remember, what type of rock is gneiss, quartzite, and marble? It's a metamorphic rock. And just as we've been talking about here, metamorphic rocks are going to be formed from that pressure during mountain building events. So it makes perfect sense that the Adirondack Mountains up here are A, that they're mountains, and B, the bedrock matches what we've just been talking about. It's metamorphic in nature. Okay, and you can do that for all of the different landscapes throughout New York State. So take a look at that, because on the regions you're going to need to know that stuff. Okay, that's pretty much it for this final lesson here. The last thing I'm going to say, on the bottom of page 15, all right, let me zoom in here. On the bottom of page 15 is a bunch of questions. I am going to be looking at this when I collect it, so I want you guys to do this practice on your own as you finish up with this video, okay? So do your practice, color in the landscapes, or just take a look at it. I don't really care if you color them in, but take a look at the comparison between the bedrock as well as the landscapes, and we'll take it from there. All right, remember, this has to be handed in by the 30th, so that's The Friday we get back, right? We have off Monday, Tuesday, so we'll be back Wednesday, Thursday, and this is due Friday. All right, so please make sure you get those in. This is a test grade. All right, I'll see you guys when we get back.